Welcome back, everyone. So, in the previous part, we were discussing the recursion by using tracing trees. So, we have discussed two of the basic examples related to the recursive function. So, we have discussed this example and this one. So, there is the minor difference between the both of these examples. So basically here the recursive function is called first and then statement was being executed and here the recursive function was called after the statement execution of the print statement. There can be any statement. Here we have taken the example for the print statement. So uh, what is the name given to these two types of the recursive function behaviors? This is basically the tail recursion. When the statement is executed first and the recursion function is performed later. So when recursive function is called first and the statement is executed later, then it is called a head recursion. So these are the some concepts related to the recursion. So let's take an other examples to go deep into it. So this is another very simple example that we have already seen in some previous slides also. So here we have taken the recursive function message. So let me show you. Here you can see here is our main function. It is taking the message of 5, taking the argument 5. So uh, here is the our definition of the message function. So here is the condition of our recursive function. So it will be checking the condition that whether it is true or false. So this will keep on repeating until this condition is true. So you can see this is the recursive function. On every iteration, there would be the decrement of 1. So this is basically how the recursion is being performed. This is the simple example of the recursion, that is a kind of tail recursion. Here statement is executed first and the function is called later. So this program is not performing anything after the recursive function. So this is the tail recursion. This is kind of this is performing same like the loop. In case of head recursion, then it would be very easier for you or beneficial for you to use the recursion concept. So I will show you in the upcoming example. This is the output for this program. This is very simple, just behaving similar to the for loop and repeating the statement until this condition is true. So this is simple program. Now it comes the concept when there is we have performed we have seen there would be the head recursion as well. So there is the you can see here is the recursive function and there is statement before that and after that as well. So let's see how it will behave. Now you will see the advantage of the recursion. So as we mentioned that it is a very strong behavior. It has very strong behavior, as in the previous slides we have when we were talking the definition. So recursion has two phases, ascending as well as descending phase. That is basically the strength of recursion. This what I mean. So now you will see how it is ascending and descending. So here you can see 3, 2, 1, and here 1, 2, 3. So here is the tail recursion, and here is the sorry, here is the tail recursion, and here is the head recursion. So we were discussing this example. Let's see. It is kind of similar to the previous example, but here you can see there is a statement before the recursive function, and there is the statement after the when this condition is false. There is the statement after the recursive function. So let's see how it will work. So once when the value 5 is given to the message function. So message called with 5 times. So here you can see message called with 5 times. It will check the condition. Condition is true. It will uh, execute this statement and then comes to the recursive function. Here it will have the decrement of 1, and this function is called again. So it will move back to the previous call. So here, definition of the function, it will move back to the definition of function, and it will execute it up till this condition get false. So when this is false, this statement will be executed. As you can see, it will be false when 0 is greater than 0. In this case, it will be false. So you can see here message returning with 0 in times. So now when this condition is false, so here the message 0 uh, 1 minus 1, it will be 0. So it will be returned back to the previous call. So now it is returning back to the previous call. So same like this thing. Now it will be printing first 0, 0, and there was the statement for the 0 as well. So it will print 1, 2, 3, 4, 5. So it is returning to the previous function and then print, then returning to the previous function and then print, returning to the previous function and then print. So same behavior it is now. So message returning with a 0 in times, message returning with a 1 in time. So you can see here it is returning to the previous function. It will come out of the loop and print, then uh, calling to the previous call from where it was called, and then come out and print. So this is how it will be behaving, uh, will be working. So you can check this when you will um, do your coding part. So let's discuss another example related to recursion. So before we have discussed the linear search. Now let's see the binary search. So we will solve the binary search problem by using the recursion and as well as iterative behavior. So here is um, the solution of the binary search by using the iterative method. So here is the recursive method. Here you can see this function is calling itself again and again. So let's discuss how binary search is performed. Basically, when I talk about the binary search, basically it will divide the whole data or the whole array into two parts. One is the lower part and one is the upper part, or you can say the lower bound or and the upper bound. You can say anything. So for this, the must condition is for binary search, the elements must be sorted. So here is our main function, and this is the array that I want to on that I want to apply my binary search. So I want to find the element, any key element in this in these elements. So here for the binary search, all the elements must be sorted. So we have taken the array, sorted array. So what we will do now, we will perform the binary search in this array. So all of these elements are sorted in the ascending order, and let's discuss how binary search will be performed. For this, if I see the binary search function, we need three variables L, mid, and H. So will be our L value with the index 0 and with the index length minus 1. Basically, this is the size of the array and this is the length of the array. Length is basically the number of elements in the array. So it will be minus 1 because it is starting from 0. 0 to 8. So here it is 9. It will be L minus 1. So this is my H. So uh, L is equal to 0, it is 0, and H is equal to length minus 1, it is 8. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. So 9 minus 1, 8. Next, we will check that whether this L, uh, of course, it should be less than H. So we will check that this is less than or equal to H. This condition is true, then we will find the mid value. Mid value is L plus H divided by 2. Our L, the value of L is 0 and H is equal to 8. So 0 plus 8 divided by 2, so it will be 4. So my mid value will be somewhere here. So that is basically small MID mid. So I am, for the convenience, I am writing it. So it is, sorry, it is difficult to write by using mouse. Uh, I am trying to arrange some blackboard to write the explanation. So L and H, uh, and this is mid. So it will be 4, 0, 1, 2, 3, and 4. So firstly, we will check the our value, that is basically that we want to search. So we will compare it with the mid value. Either the mid value is our key value that we are searching for. If it is uh, fine, means that if it is equal, our mid value is equal to the search value, it will return the mid value. If it is false, if this condition is false, it will check here the key value that we want to search is less than the mid value. So if it is less than the mid value, it will check in this area. So if it is not less than the mid value, it will check in this area. And what else it will perform? So when this condition is satisfied, the key value is less than the mid value, what it will do, it will assign H is equal to mid minus 1. So this h value, our upper bound value will become here, and the index would be mid minus 1. Here the index in the mid was 4, 4 minus 1, 3. So it will take search the our key element within this range. So between 0 to 3, 0, 1, 2, and 3. So it will check here if this condition is true. So if this condition is not true, obviously key would be greater than this. So what it will do, it will basically assign L is equal to mid plus 1, yeah, means L will become here, and it will become check between L and H. So the value of L would be mid plus 1. So it was 4. It the value of the mid was 4. Now it will become 5, and from here to here it will find try to search the element. So this is how we are performing the binary search. We are basically finding the L value, not finding, we know the lower bound and upper bound, and we are finding the mid of them, and on the basis of mid we are finding, we are dividing our search into two parts, lower part and the upper part, and from in the if this condition is true, then it will find it in the lower part. If this condition is false, it will find it into the upper part. This is how it would be repeating up till this condition. So for example, we are finding the value 16. So this is will be here in the this part. So it will divide the array into smaller and smaller patches like this, between L and H. Again, it will find the mid. So if the uh, mid is calculated by the same method, next time here L will be same 0 and H will be 3. So 0 plus 3, it will be this. Next, then it would display the value. So is this? So this is how the binary search is being performed. So one more thing, you should keep this thing in your mind, that when it is a kind of situation when there is the odd number, for example 0 plus 3 divided by 2, so it will be 1.5. So we have to apply the floor operation. So it would be 1. So the mid value between, we have to check between 0 to 1, and then 1 to the higher value. So we will be applying the floor operation on the mid value in case of the odd number, sum of the odd number. Okay, so this is how the binary search will be performed. Next, mm, this was the iterative version. Let's see the recursive version. So here is the recursive version. Let me. Okay. Binary search from the array. Same rule will be applied in case of the recursive variant. Most of the things are same. So structure array, display, here is our main function. So here we have taken this array. So here the size is 10 and the length is 5. So here is the R binary function, the recursive binary function. So in this, we are giving these function parameters by ourselves. As you can see here, we are giving the array and lower value, the upper value, and the key element. So this is the difference, and as compared to the previous one. And here is our recursive function, and here it is calling itself again and again. So before we have applied the iterative approach, now here is the recursive approach. So the method of calculating the searching the binary element is same. So here it is taking these parameters, mm, low, high, and key. So we have initialized the mid value equal to 0, and if L is less than or equal to H, means that our lower bound value L is less than or equal to H. Lower is in the start, lower will be 0, and higher will be uh, equal to the length. So it will check this condition, L plus H divided by 2. So it will check whether this the key value is basically 5 here. It will check whether the key value is equal to the this mid value that is obtained after adding L plus H divided by 2. So from here we will obtain the mid value. So here the mid value is this one, and this is L, and this is H. Similarly, you are familiar with these terms now. So if it is found, it will return the mid value. If it is not found, it will check in the lower bound, same like previously. So here was M, so it will check in this area. So else, if it is not found in this key is not less than A of mid, uh, in other case, it will check in this area between M and H. So here it is recalling the function. So here it is assigning mid minus 1 and mid plus 1 within the function, the thing that we were performing here. Here h value was assigned mid minus 1 if key was less than this, and if this is not the condition, key is greater than this in this upper part. So we were assigning L is equal to mid plus 1. This thing is being performed here, mid minus 1 and mid plus 1. So this is how the recursion by binary search by using recursion operation is performed. So this is the main function, and it will display, and here it will display the index where that particular element is found. In case of 5, if we are searching for key 1, it is here. So 0, 1, 2, and 3. It will display 3. And this will display the array. This. Okay. This is the example related with the binary search. Let's check another example of recursion. For example, if I want to add the n natural number, so it is very simple. I will explain you by using simple method, by using iterative method as well as by using recursion method. So here is our main. It is calling the function sum. So this is simply sum taking the value 5. So it is checking if it is equal to 0, return 0, else it is adding. So it will, here it will be 5 and here it will be uh, 5 minus 1. So it will call it again. So this is the recursive function. Here it is the iterative version by using simply the for loop. So this is how it is initialized with 0 and it is adding the previous values on every iteration. So it is storing the previous value s is equal to s plus 1. So and returning this value s. So you are already familiar with this loop, what it is performing. So same thing is being done by using the recursive function by using the concept of recursion. So let's see another example. It is similar to previous one. Before we were adding sum of n natural number. Here we are multiplying, basically finding the factorial of n. So by factorial, I mean if I want to find the factorial of 4, so it will be multiplying all the previous numbers. For example, 4 multiplied by 3 multiplied by 2 and multiply by 1. So this will be the answer for the factorial of 4 and it is represented by this sign. So 4 multiplied by 3 multiplied by 2 multiplied by 1. So this is by using the iterative method and by using loop. So here it is mm, multiplying it with the previous and storing it into the variable f. So here it is using the recursive approach. So on every function call, it is subtracting it with 1, having the decrement of 1 and performing the recursive operation, recursive function operation. So this is all for today's lecture. So let's we will discuss uh, the remaining things in the next lecture. Thank you. Have a nice day.